This is Algebra 2, Unit 5, Lesson 6. Today we're going to solve equations involving radicals. And you're going to find that you're going to have equations that have radicals with variables underneath, and we have to understand step by step how to solve those. So I'm going to let you pause the video. There's a 5-step method to this, so go ahead and copy down the 5-step method, and then we will follow this method to solve our first few problems. Okay, now that you've had time to write down the method, the first thing that it says to do is to isolate the radical. That means you're going to get the radical completely by itself first. So if you look at this first thing now, it also says to do that if possible. There may be occasions where there are two radicals in the same problem. When that happens, that's a little more complicated. We won't cover any of those in this section, but that is something that we may have later in the Algebra 2 curriculum. So to do this first one, I'm going to isolate this radical, get it by itself. So in order to do that, I'm going to divide both sides by 3. When I divide the left side by 3, I end up with the square root of x minus 2 equals 4. And then once the radical is by itself, in the method it says for step 2, to square both sides. So hopefully you remember from doing our work with radicals that when you square a square root, they undo each other. So as long as we're doing the same thing on both sides of this equation, you're allowed to do that. So I'm going to square the left-hand side and the right-hand side, and the purpose for me to do that is to get rid of the radical, because I can't solve the equation until I get rid of that radical. So if I square this side, the square root cancels out, and that becomes x minus 2, and then 4 squared is 16. At this point, we would solve the rest of the equation. I'm going to add 2. So x equals 18 would be my answer. Next, we have to check the answers. All of the answers that you get are not going to work. Sometimes you're going to have to throw answers out because it just mathematically doesn't make any sense. So you would take what you get, plug it back into the original. Make sure you're plugging into the original to check the solutions. So if I plug 18 in, 18 minus 2 is 16, square root of 16 is 4, and 4 times 3 is 12. So that does work. We can keep x equals 18, and then we don't have to do step 5. We don't have any answers that didn't work, so we don't have to throw out any of the answers. In this one, in order to isolate the radical, I'm going to add 3 to the other side. That leaves me with 3m minus 3 underneath the radical equals 3. Then again, to get rid of the radical, I'm going to square both sides. When I square the left-hand side, I get 6m minus 3. When I square the right-hand side, I get 9. Then I have a simple equation to solve. I'm going to add 3, divide by 6. I end up with m equals 2. I will take that answer, plug back into the original equation. 6 times 2 is 12. 12 minus 3 is 9. Square root of 9 is 3. 3 minus 3 is 0. We can keep that answer. Nothing to be thrown out there either. In this one, I'm going to subtract the 7. I've got the square root of 2x plus 3 equals negative 5. I'm going to square both sides. When I square that side, I get 2x plus 3. When I square this side, I get 25. I'm going to solve what's left. So I've got 2x equals 22. So x equals 11. And then I have to check my solution. 11 into the original equation. 11 times 2 is 22, plus 3 is 25. Square root of 25 is 5, and 5 plus 7 is 12, not 2. This doesn't work. It gives me a false statement. I have to throw that out. Now, since that was the only answer that I got when I did the math, there are no solutions to this problem. So I would write no solution. In this one, here, Notice this is a little bit different. We have an x over here. All the ones that we've done so far have just had a number over there, no variables. So this one's going to be a little bit different. I'm still going to start it the same way. I'm going to isolate the radical, and I'm going to get the 1 on the other side. So I've got the square root of 9x minus 11 equals x plus 1. And then if I want to get rid of the radical on the left, I do still have to square both sides. But when I square the right-hand side, look at what I end up with. I end up with something that I'm going to have to FOIL. I have a binomial squared. Now, we've learned how to square a binomial. We learned it in Algebra 1, and we have reviewed it this year. If you can square that binomial without doing any work, that's fine, but I'm going to show you how to do that just in case you've forgotten. That means I'm going to write it down twice, and then I'm going to FOIL it. First, outside, inside, last. So the first terms, x times x is x squared. The outside terms give me 1x. The inside terms give me 1x. And the last terms give me 1 when I multiply. So if I add my like terms, I end up with x squared plus 2x plus 1. And then if I square the radical, I end up with 9x minus 11. So I have 9x minus 11 equals x squared plus 2x plus 1. Now again, if you can do this, go straight from here to here without any work, that's fine. You shouldn't have to do all that work, but if you still need to get it right, then certainly show the work that you need. With this, we learned in the last section that if you have a polynomial that has a degree higher than 1, in order to solve that polynomial, you're going to have to factor. So the highest degree here is x squared. So that means we're probably going to have 2 answers if we solve that by factoring. So if we solve that, we also talked about in the last section that we want the x squared term to be positive so that it's easier to factor and we don't have to account for that negative. So the x squared term is positive on the right hand side, so I'm going to keep everything on the right hand side. So I'm going to have to get it equal to 0 in order to factor, but that means I'm going to move the left hand side over to the right. So when I do that, the left hand side will now be 0. And then if I move those terms over, I have x squared, 2x minus 9x is negative 7x, and 1 plus 11 is 12. So to factor that, we're looking for factors of 12 that add to give you 7. Well, factors of 12 that add to give us 7 are 3 and 4. So I'm going to factor this. I know I'm going to use x and x. I know I need 3 and 4. The plus tells me the signs are the same as what this is, so they're both minus. Then, like we learned in the last section, when we factor and we have 2 binomials, we set each binomial equal to 0 to solve. So I have 2 answers, x equals 3 and x equals 4. And then the next step for solving radical equations is to check those. So we're going to have to take both of these one at a time and plug back into the original to see if they work. So if I plug 3 in, 9 times 3 is 27. 27 minus 11 is 16. Square root of 16 is 4. 4 minus 1 is 3 equals 3. That works, so we keep it. If we plug 4 in, 9 times 4 is 36. 36 minus 11, 25. Square root of 25 is 5. 5 minus 1 is 4. That equals 4. So that does work as well. So we're not throwing out any of those answers. We're going to keep them both. It is okay. Sometimes you might have 2 answers that both work. No problem there. So you might not have any answers. You might have some that are no solution. You may just have 1 answer where you keep 1 and have to throw 1 out. You may have 2 answers that both work. You may just, when you solve it, end up with just 1 answer, and that 1 answer works. So I've got 2 more we're going to try here. In this one, the radical has already been isolated for you, so in order to get rid of the radical, I'm going to square both sides. This one will give me a 7x minus 12 on that side equals x squared. Again, my polynomial has a degree higher than 1, so I'm going to get everything with that x squared so that I can factor it to solve it. The x squared term is positive on the right, so I'm going to move everything to the right. So the left side will be 0. I've got x squared minus 7x plus 12. I'm looking for factors of 12 that add to give me 7. Looks like this one is going to end up with the same factoring that the last problem had. So we've got x minus 3, x minus 4. And when I plug back in, I'm plugging into the original. Now remember, the original did not have those squares. I added those in. So I'm going to check. If I solve that, I get x equals 3 and x equals 4 as my two answers. So let's see if they work. If I plug 3 in, 27 times 3 is 21. 21 minus 12 is 9. The square root of 9 is 3, and that equals 3. So that one works. If I plug 4 in, 28, 4 times 7 is 28. 28 minus 12 is 16. Square root of 16 is 4. So that, again, works for that one.